click the bell icon for the latest update. Today we're gonna start with your quantitative aptitude class, that has been the 172th class of the session. In the same, in quantitative aptitude, we had started with the arithmetical ability. In that we had started with the pipe and cistern. Wherein the last topic we had covered up is your time and work. That is the 15th topic we had done in arithmetical ability as well. Coming towards your pipe and cistern, before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, even though you can also enjoy the video as well. So here we go. In terms of pipe and cistern, we'll first understand about inlet and outlet. What were the inlet and the outlet, and how it performs in a question that we are dealing here. So first we'll discuss about inlet. So in terms of inlet here, inlet states that a pipe that connected with a tank or a cistern or a reservoir that fills it in, and that is known as an inlet. In terms of outlet here, a pipe connected with a tank or a cistern or a reservoir that emptying is it is known as an outlet. Talking here, a pipe connected with a tank a pipe connected with a tank, the tank or a cistern or a reservoir or a cistern or a reservoir that fills it. Is known as an inlet. Okay. Now coming towards outlet here. In terms of outlet, a pipe connected with a tank. With a tank or a cistern. Or a reservoir. That is emptying it. It is known as an outlet. Okay. So now we go for in the detail. If the pipe can fill a tank in X hours, then part filled in 1 hour. That what we'll have to find it out. So we go here, and that has been the important one. So the first we have, if a pipe can fill a tank in X hours, then part filled in 1 hour equals to 1 by X. The second we have, if a pipe can empty a full tank in Y hours, then part emptied, in 1 hour equals to 1 upon y. Now for the third one, we talk if a pipe can fill a tank in X hours and another pipe and another pipe can empty the full tank in Y hours, where Y is greater than X, then and opening both the pipes the net part filled in 1 hour goes to 1 upon X minus 1 upon Y. The fourth one we have, if a pipe can fill a tank in X hours and the another pipe can empty the full tank in Y hours, where X is greater than Y, then in opening both the pipes, the net part filled emptied here. If a pipe can fill a tank in X hours and another pipe can empty the full tank in Y hours, where X is greater than Y, then and then on opening both the pipes, the net part emptied that is emptied in the form emptied in 1 hour, which is equals to 1 upon Y minus 1 upon X. Now the fourth condition we talk here, which is the fourth condition, that is if a pipe can fill a tank, that we had done even fourth conditions. So these were the 4 conditions we will talk about it. Now we go for the question, and that is the first question of piping system. 2 pipes A and B can fill a tank in 36 hours and 45 hours respectively. If both the pipes are open simultaneously, how much time will be taken to fill the tank? That has been the question. Now we're going to answer with this, and that has been as follows. Let's find out the solution for the same, the first question of the session. Here we go. So the first question we have 2 pipes A and B can fill a tank in 36 hours and 45 hours respectively if both the pipes are opened simultaneously. How much time will be taken to fill the tank? Now we find out the solution for the same. That is of course the important one here. So here we go. Part filled by A in 1 hour. Part filled by A in 1 hour equals to 1 by 36. Part filled by B in 1 hour equals to 1 upon 45, and part filled by A plus B in 1 hour equals to 1 upon 36 plus 1 upon 45 equals to 9 upon 80, 180. 9 ones are 9 and 9 twos are 18 and 0, that is 1 upon 20. So hence both the pipes together, hence both the pipes together will fill the tank in 20 hours. Now we go for the another question here. Now we go for the next question, that is second question is, two pipes can fill a tank in 10 hours and 12 hours respectively, while a third pipe empties the full tank in 20 hours. If all the three pipes operate simultaneously, in how much time will the tank be filled? That has been the question, and now we have to answer it out accordingly. So we go for the same. First we go for the question, that is the second question. Two pipes can fill a tank in 10 hours and 12 hours respectively, and 12 hours respectively, while a third pipe empties the full tank in 24 hours. If all the three pipes operate simultaneously, in how much time will the tank be filled? that's what we have to answer it out. So let's go for the solution here. So net part filled in 1 hour equals to 1 upon 10 plus 1 upon 12 minus 1 upon 20 equals to 8 upon 60 equals to 2 upon 15. So the tank will be full in 15 by 2 hours, that is 7 hours 30 minutes. Now we go for another one, which is being the another important question, being the third question of the session. Question is, if two pipes function simultaneously, the reservoir will be filled in 12 hours and one pipe fills the reservoir 10 hours faster than the other. How many hours does it take the second pipe to fill the reservoir? Okay, so we go for it. That is, we have your question here. That has been the third question. So we go for it. If two pipes function simultaneously, if two pipes function simultaneously, the reservoir will be filled in 12 hours. Will be filled in 12 hours. One pipe fills the reservoir. Fills the reservoir 10 hours faster than the other. How many hours does it take second pipe to fill the reservoir? Okay, so for that we will talk about it and we'll have to find it out. So let the reservoir be filled by first pipe in X hours, then the second pipe will be filled in X plus 10 hours. So let's go for it. Here we go. So let the reservoir be filled by first pipe in X hours, then second pipe will fill it in X plus 10 hours. So 1 by X plus 1 upon X plus 10 equals to 1 upon 12. It will be X plus 10 plus X upon X. X plus 10 equals to 1 upon 12. Further, x square minus 14x minus 120 equals to 0. So x minus 20, x plus 6 equals to 0. So find it out, x equals to 20 here. So the second pipe will take, so here the negative that value of x, neglecting that negative value of x, so the second pipe will take 20 plus 10 hours, that is 30 hours to fill that reservoir. We go for the another question, that is the fourth question of the session. And the question is, a cistern has two taps which fill it in 12 minutes and 15 minutes respectively. There is also a waste pipe in the cistern. When all the three are open, the empty cistern is full in 20 minutes. How long will the waste pipe take to empty the full cistern? That is being the question. So we have to answer it out accordingly. Let's go ahead. Let's find out the solution, of course. That is the fourth question of the session. So the fourth question we have, a cistern has two taps which fill it in 12 minutes and 15 minutes respectively. There is also a waste pipe in the cistern. When all the three are open, the empty cistern is full. In 20 minutes. How long will the waste pipe take to empty the full cistern? Now we find out the solution here, which is being as follows. Work done by the waste pipe in 1 minute. In 1 minute, that is equals to 1 upon 20 minus 1 upon 12 plus 1 upon 15, which is equals to minus 1 upon 10. So negative sign means that is empty. So waste pipe will empty the full cistern in 10 minutes. Now we talk about for the another question, but that will discuss in the next coming class. Okay, we'll continue here itself so that it will be helpful for you. So here we go for the fifth question. The question we have as follows. An electric pump that can fill a tank in 3 hours because of a leak in the tank. It took 1/2 hours to fill the tank. If the tank is full, how much time will the leak tank to empty it? Okay, so that we'll have to solve it out. Here we go. An electric pump can fill a tank in 3 hours because of a leak in the tank. It took 1/2 hours to fill the tank. If the tank is full, how much time will the leak take to empty it? Okay, so we'll find out the solution here. Work done by the leak in 1 hour equals to 1/3 minus 1/7/2, which is equals to 1/3 minus 2/7 is equals to 1/21. The leak will empty the tank in 21 hours. Now we're gonna start earning it up with this. Then we'll discuss the 6th question in the next coming class, which is of course in your 173rd class of the session and 173rd class with the 6th question. So here we're gonna end up with. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Please like, share and subscribe, of course. Other than quantitative aptitude, we are dealing with the chemistry part 1 we had done, and part 2 we are dealing physics part 1 we are dealing for class 11 NCERT as well. Coming towards reasoning, we had done, we are in the verbal reasoning and the non-verbal reasoning. Coming towards, we are dealing with the CBNST, DPMS, and we are dealing here in the quantitative aptitude. We had started with arithmetical ability, that is the first part of this quantitative aptitude. Here in that as well, we had done numbers, operations on numbers, SCF and LCF of numbers, decimal fractions, simplification, square roots and cube roots, averages, problems on numbers, problems on ages, certs and indices, percentage, profit and loss, ratio and proportion, partnership, chain rule, time and work, pipe and cistern, time and distance, problems on train, ports and streams, allocations on mixture, simple interest, compound interest, logarithm, area, volume and surface area, then races and games of skills, calendar, clock, stocks and shares, permutations and combinations. After that we talk about it. So yes, we had done a probability, to discount, bankers discount, height and distance, odd man out series. In data interpretation, we have to cover up the tabulations, bar graph, pie chart and line, that is line graph. Thank you. Please go ahead with subscribe.